more. We are truly honored to have you with us, sir. Now I request Mr. Rishi Cherkuri to continue with the session. Thank you.
Can you hear me all? Hello? Hello, can you hear me okay? Now it's audible, ma'am? Okay. Hi all, this is Rishi. Thanks for and able to I'm going to share. And just before we get started, the fact is that you could also use the raise hand option just in case you have anything, and basically you can maybe type in the chat as well as to if you have any questions. And without further ado, we can get started. You would definitely see the option of raise hand, I guess. If not, try to look for that. Let me just move this away. Okay, thanks for confirming. So when Wali ma'am and the IC invited related to blockchain, so we were thinking how are the topics related, and cybersecurity and blockchain. So I think that's one thing that you could expect to get covered today. So brief introduction about me, and Varun has already done this. So I have worked in IT for 15 years and enabled workshops at multiple organizations like DRDO, Geetham, Gayatri, and also we do several meetups in the name of Decentrum. So Decentrum is a community. So I work with Nagaro as a technology architect. So on the right hand side, you would see that there are all the organizations that I worked with in the past. And I'm happy to be here helping you all understand about blockchain. So can we see a show of hands as to how many of you have basics of blockchain already? Let me try getting this as well. Okay, quite a number of people are here saying, okay, we know about the basics of blockchain. That's great. Okay, so this is the agenda that we have set upon. So why blockchain? Centralization versus decentralization, differentiating cryptocurrencies from blockchain. Uh, you can learn about blockchain by building one, but I'll share that link to you towards the end of the session, and you could definitely try and learn blockchain by building one. I'll show you a couple of examples as to how to understand blockchain and what do we mean by distributed ledgers. Then the popular platforms to be used for distributed ledgers, use cases and applications of distributed ledgers. So whenever we use this word blockchain and distributed ledgers, we are using that interchangeably. So you could consider them one and the same, right? Now, again, coming to why cybersecurity and blockchain, I think if you are familiar with the world of cybersecurity, you are looking at the cybersecurity information triad, which is about CIA. That's what it's commonly known as, and most of you who have been working in this space know this. So the confidentiality, integrity, and availability. These are the three terms that define the information security triad for data security. And blockchain, in a way, addresses the confidentiality, the integrity, and availability. And over this period of 5-day workshop, you would learn multiple things. So I'm happy to have the first session introducing blockchain to you all. So what are these two worlds? So what are these two worlds of blockchain and cybersecurity, and how do they get related, right? So if you have heard about blockchain in the past, you would have heard about Bitcoin, or you would have heard about Ethereum, or you would have heard about multiple other things like Ripple and all of that, cryptocurrencies per se. So they are more of applications of blockchain. They are not blockchain as such. So the underlying technology, just like any web application today, has a database behind it. Blockchain also is a technology that enables trust and truth in terms of the application. So it is more of a database only, but in a distributed way. So we'll explore what does it mean by blockchain and distributed ledger technology over the course of next 90 minutes. So the cybersecurity that we are talking about is also about protecting the truth, thereby enabling trust. So since both blockchain and cybersecurity are about truth and trust, so they have a very good relation between each other, and they combine together in terms of confidentiality, integrity, and availability. So, so coming to confidentiality, what does it mean by confidentiality? If I send some information to somebody, they are the only ones who are supposed to be able to look at it. So in a way, you should be able to secure this by using cryptography and various other algorithms that are available. And blockchain enables this by using encryption by default, or you can say cryptography by default. We will, if you are new to this, we can explore in the next few slides about what do we really mean by this. Then integrity. Once the information is stored on blockchain, how do we make sure that that's always there and available? So that's and in a way that it is untampered. So that's what is integrity all about. And availability is about if something happens to the information at one of the places, how do we make sure that we can easily get a replica of that in an untampered way from somewhere else? So these are the triads of CIA. And let's go to the next slide. So this is the cybersecurity news from last week. I'm not going to read each and every word from here or the paragraphs that we have here, but you can see just within last week, there are so many things that are happening within the cybersecurity world. A city in US is infected, and they are demanded for a ransomware. There is a bug in Facebook messengers, or Windows has released the largest ever security patch. So as and when we go more online to do our businesses and conduct our way of life on the online world, it's also more important that somebody doesn't impersonate us and somebody doesn't misuse the information that we have there and held us hostage for various aspects that keep happening around the world. But I think you get the gist that there are so many things that keep happening about cybersecurity. Just in last week, this is what it is. But you can all remember the kind of cybersecurity incidents that have happened that have affected everyone in a severe way in the past, right? So data is very important, and we need to keep it secure, and that's what cybersecurity is doing. Now let's come to blockchain. So in a way, we already have figured out that okay, blockchain and cybersecurity, they have a relation inherently. So try to see if you can find questions that are familiar to you. And this is about why we would need blockchain and distributed ledgers. So let's say, for example, the question is the person about 21 years of age? So this is something that you could get asked whether you go for voting, whether you apply for a bank account or something else. That's the question that really is to be answered. But what do? We give our Aadhaar card, we give our PAN card, we give our address proof, we give a lot of other things to prove that we are eligible to open that account. And all the important things about that is the person about 21 years of age and is the person who he says he is. Now let's say I go to a bank account and say I'm Rishi and I want to open a bank account. They'll ask like, okay, where's your Aadhaar card? And they just don't want me to show that, they want a copy of that, right? And this is an experience that probably most of you would have gone through when going for voting or opening a bank account or any other approach. So identity is one of the important aspects that is there in the society today. And if you can identify yourself as whom you say you are in a way that everybody can trust, you don't really need to keep sharing your Aadhaar cards and all the other identity information that you have about you. And one of the other things I think in the post-COVID situation, this has also become more important. That a lot of organizations are saying we are selling organic products, and this food produce is really good. It boosts your immunity and so on and so forth, right? So how do we make sure that this food that they are selling is really organic? So how do we keep a track of that, right? And someone comes to your organization, applies for a job, and says, "I have 15 years of experience. How can we validate that?" Right? And all of this are already happening today in one way or the other through certifications or through background checks or through other cards like we just discussed. But all of these processes of verifications take time. And why do they take time? A lot of this information is there in physical world. It does not really have a digital replica. Or in certain cases, you have a digital replica and you are able to verify that. But you have so many standards today. Like for example, PAN card is there, Aadhaar card is there, driving license is there. So these are all the identities that are there around you. Some organizations give you online information access very easily, and some don't give you that. Then a lot of other things, and especially vaccines. So vaccines are supposed to stay in a temperature range of 2 to 8 degrees centigrade. And if that doesn't happen, and you are given that vaccine, let's say there is a cure for corona, and it's in the form of vaccine. Of course, until then you'll need to make sure that your immunity is good. But let's say this vaccine did not stay in the temperature range, and you are given the vaccine, and everybody thinks that okay, if I'm given vaccine, I can be bulletproof to corona or another disease, right? But if this did not really meet the temperature range, how do you make sure that you are able to validate that, right? So there are so many other use cases and so many other questions that are there today, that go unanswered or that have a very hectic way of validation and verification. So blockchain in a way is going to help solve the problem. But let's not just believe what I'm going to say. Let's just ask ourselves the question, why blockchain or distributed ledgers? So in all these problems that you see around the world today, the most important thing is about decisions and information sharing. So whether we are able to share the decisions that we need to take, and we need to find answers to the due diligence in terms of those decisions. That has been the case since humankind has been evolving over a period of time. And this is a slide that talks about that in terms of what do we really mean in terms of decisions. So these are the questions that we are asking, right? If the person is about 21 years of age, then you can give them a bank account. That's one kind of a decision. So think about it. How could it happen in a pre-internet era? Okay, so in a pre-technology era or pre-1900s, there are not many banks. So uh, all that used to happen is it used to go on trust, and more in those days, mostly whoever is in a locality knows everyone. Okay, so even in villages today, you could see that everybody knows everybody, right? If you come to cities, that change. If you come to apartments, that change. But basically things have changed from pre-internet era, right? So today if you decide where this information is and how decisions are to be taken, let's take for example Vizag. So you have so many wards, you have so many people living in Vizag, and each of them represents their decision making in terms of their voting and the votes that they cast, right? So in a pre-internet era, you would vote for someone, and basically there is this phone, or you either meet them in person. Then you kind of take a decision whether you are, I mean, whatever is the decision that is supposed to be taken, whether it is 21 years of age in terms of voting and so on and so forth. So there's a way that pre-internet era business used to get conducted. So what was wrong with it? So as long as everybody knew everybody, there's no problem. And as long as people are not traveling, there's no problem. As long as you don't do business with worldwide organizations, there's no problem, right? But once you want to do all of that, that's when internet era came into picture. And here you can think of this as how do we tell ourselves about tell about ourselves to the world, right? So a website could be made, and in the internet era you could also see that the e-commerce came into picture. You want to order for anything, you could order that through internet, right? So this was about 90s and 2000. So that's when the internet era actually bloomed, and a lot of companies which came into the dot com bubble have. Having a website in that time is really a great thing to have. Today, you want to have a website, you just go to GoDaddy, register a domain, and maybe within half an hour, 1 hour, you have some content that you want to expose using WordPress, right? So that's about internet era. But in this case also, decisions that are to be taken, what products do I need to sell, which one do I want to buy, and all of that used to happen from within the internet era itself, right? And today in this internet era, we are also making the using the advantage of the internet era. So we are all able to speak using this internet era. And I asked you a question, how many of you are familiar with blockchain fundamentals before? So several of you raised hand. So that was near instantaneous response we were able to get from people across India. And if you think about it, in a pre-internet era, this would not have happened, right? So I would either have to publish a book, or I would have to write and publish a newspaper, and then you would get the information you need. So then what happened is, from internet era, it got a bit of transition into peer-to-peer systems. So peer-to-peer came into picture in terms of censorship resistance. And you could see that happening in the world of torrents today. So if somebody has a file, not really about movies and music, but somebody has a file and they want to share with others, and they want to do it with a boundaryless way of sharing information, then it is peer-to-peer. So what do we really mean by peer-to-peer? I don't have a centralized website, or I don't have a centralized server which is distributing all the information. There are multiple servers over the internet that are able to transmit information between each other. And let's say I have a file that I want to share with you all, maybe this PowerPoint itself that I want to share with you all. I'll give it to, I'll initially seed the file, and from there, I'll give it to 3 people, and those 3 people will give it to 9 people. And after that, it multiplies and multiplies, and everybody has a copy of this document, right? So that's what our peer-to-peer system. So nobody can basically say, come here and say, shut down the central server, and the file is gone. So in this way, you have a better uncensored network in here. So these uncensored networks led to blockchain. So what really led to blockchain is, you can say, the financial collapse of 2008, the subprime organizations, and people not having money, say they are able to, they have a lot of money. That's what led to the subprime organization. And in blockchain world, this is called double spending. Spending money that's not there and trying to avoid that. That's what is double spending all about. And in 2008, Satoshi Nakamoto, this guy came in and said, "Yeah, I have this brilliant idea called Bitcoin. And anybody, this is called internet money. Anybody can send money to anybody. And across the world, if this system dissipates, then no government would able to control it." So this also gave a negative connotation to Bitcoin, saying that how such kind of internet currency could be used for real physical transactions. And a lot of people also made use of this to pay for drugs, to pay for weapons on the dark web and all of that. So which gave negative publicity to Bitcoin. But really, it's a brilliant concept that uh, whatever we are trying to do, we are trying to exchange value, we are trying to exchange decisions, and over Bitcoin that happened. So that's what is about Bitcoin. And this guy Satoshi Nakamoto came and said, "Hey, let me share this white paper with you all, and if you all like, then we can start building up this system." That's what happened in 2008. By 2009, the initial system was built, and then 2010, much more people joined that bandwagon, and it used to be in a very small amount. So every Bitcoin used to cost like 0.01 cents or something. So that's what happened with Bitcoin. But what it solved is also the problems of democracy. How people within the Bitcoin network could interact with each other to take decisions using the peer-to-peer mechanism. Excuse me. So that's when the origin of blockchain happened, through Bitcoin. So think about it as an Oracle database to help content of the website, right? So Bitcoin also used blockchain, though the term blockchain did not really exist until 2012, 2013, which is when people came and said, okay, here is what we can call as blockchain. And we can have all the information being delivered through blockchain. So instead of each organization having their own copy of a database, what blockchain did is take all of these copies and distribute it among the network, right? And that's when blockchain really started to make sense in the sense that you don't really have to have every copy and host in a centralized organization. You can dissipate this information across the world. That's what Bitcoin was making mention about. So that's what is blockchain. And then today, even if you see blockchain, and if I have some information and I want to share it with everybody, how does it happen in terms of transition or in terms of network dissipation from blockchain to anyone else, is where the IoT and AML come into picture. Say, for example, you take the case of the vaccine temperature that we talked about in the previous scheme, right? So if vaccine temperature is recorded by a person, there is every chance that somebody pays the money, and that information can go wrong. So in this case, you need real hardware talking to your blockchain. Sorry, talking to your blockchain. But if there is no truth in it, then the information is not valuable. So that's what it is about. So it's about data, it's about insights, and it's about storage. So all three of them combined is what can make a future state great. So today we have a lot of blockchain applications and a lot of blockchain systems that are taking care of many things, but we are not there yet in terms of complete decision making autonomy, right? And I'm not talking about artificial intelligence, but I'm talking about, if you need to take a decision, where is all that information available? So the answer to that question, in this case, whether my vaccine stayed in range. Wouldn't it be great if you have a mobile application which scans the vaccine barcode and basically tell you in green or red whether this has met the temperature range or not, right? So that's what is the capability that blockchain gives you. And today there are a lot of things. I mean, in the name of blockchain, there is a lot of decentralized innovation that happened. Let's also take a look at what do we really mean in terms of. Uh, so just like we talked about in the previous slide, consider that we need to maintain 500 names of people who are attending this workshop. And let's say the ceiling is 500 and the registrations are more than 1,000 from what I have heard. And everyone who is attending is confirmed. And let's say there is a list of that confirmed. So today the easiest way is to share that list and basically share the invite with all of them, and that happens from this centralized place. And we all came and clicked that link and came joined the WebEx, and that's what is centralized. So it's not that centralized is bad. For certain problems, centralized is good, and for certain problems, centralized is not good. For example, if you put all the information at one place and that fails at some point of time, and let's say we only have one server to maintain that, and there are thousands of people accessing that, right? In that case, centralized is not a good place to keep the information. But today, we are able to listen to each other because all of this information is being broadcasted through a centralized mechanism from WebEx. So centralized is good in that way where it is needed, right? Where do we need decentralized? So decentralized is needed when you want to have fail-safe systems that are able to come up even though one of the fails. So in the second diagram that you see here, you can see that there are multiple branches here, and these are subtrees, and each dot that you see here, consider that as a node, and there is a central place from which the information is getting dissipated. So here you can see four of these nodes talking to each other, and four of them have live copies of each other. So in a way, today's clustering mechanisms and high availability, they already do this decentralization to a great extent, right? So what's missing here? So let's say this guy who is trying to validate some information always needs to go to this guy who is having the information at a decentralized place, right? And let's say these four people who are hosting this network kind of colluded and said, okay, let's add 501 name into this particular list, right? So it just takes these four people to decide that, okay, let's alter the list. So then, though information is shared, there may be problems with the truth. And that's where a decentralized and distributed system makes sense, in as such that each and every one has a copy of this information, and this copy of information is validated by everybody else, and that results in a great system. And that's a kind of system that can enable something like Bitcoin, that can enable a so that nobody can question the integrity of how the voting happens or how decisions are taken in terms of an organization. A much more evolved version of this distributed system is what is called as a decentralized autonomous organization. For the sake of keeping this discussion simple, let's not go there. But these are about your centralized, decentralized, and distributed systems that can help create a web of information. And it's not that one system is good, one system is bad, but inherently, if you have the capability to build a decentralized and distributed system, and most of the problems are solved through that mechanism, it would be nice to have distributed systems than centralized systems, right? Are there any questions so far? I'm just watching the chat. Okay. Varun, if there are any questions, you can please read out. If not, let's move forward. All right. Assuming that there are no questions. So blockchain is blind. There is a blog that I have written about it. And the reason why we call blockchain is blind is also because, like we were talking earlier in terms of this AI triad, if somebody needs to know the truth, the information better be good from a good source. And when we mean a good source, what we really mean is, if somebody provides the information about vaccine, like we were discussing earlier, if that is a person from where the information is coming from, then there is all the kind of there is all kinds of problems that can arise of it out of it, either due to collusion or either due to misreadings or any of those things. And one more thing is, it's not practically possible also that somebody keeps driving with all these vaccines around and there is one person keeping a track of it, so they will lose control of all that information. So that's what it is. The data is the new oil, and the trust in data is depleting. So the manual data entry, which we are talking about just now, is prone to collusion and leads to mistrust. So what can we really do? So we need to combine the technology of blockchain and Internet of Things and machine learning and computer vision, or in other words, artificial intelligence, to be able to merge all of these things together and create an ideal system where source of information is guaranteed, that information can be easily distributed, and that can be analyzed. Right, so that's what it is about. Blockchain is blind. Let's examine further in terms of any technology concepts that you need to understand about. So this hopefully gives the introduction, and by now you understand what blockchain is and what is the relation of blockchain to cybersecurity. Okay. So let me just proceed forward to the next logical topic, which is the technical concepts of blockchain and basically distributed ledgers. Okay, so we already talked about the Satoshi Nakamoto, but there are so many things that you would have heard about blockchain before. So you can raise your hand if uh, if you have heard these terms. If you can hear me, okay, too. Okay, I can see a few raised hands here. Okay. All right. So thank you. So these are all the terms that are commonly appearing across the blockchain spectrum, and cryptography, of course, is the very important aspect of this. So in other words, hashing, as what it is known as, and public key and private key infrastructure, PKI, in other words, you would have definitely heard about it if you are familiar with cybersecurity. The words like ciphers and the words like hashing and RSA, SHA. So all of these algorithms that you would have heard about, these are what make blockchain. So in other words, blockchain is not something that that just emerged all of a sudden with all new technology. There have been a lot of other terms and a lot of other algorithms that have been there from the history. Maybe even even prehistoric era and even before internet has started. Okay, but after internet has started, there is this cryptography, there is this ciphers, and how you can communicate with one another without the third person recognizing the information that's being sent. So so that's what is blockchain doing. It took parts of cryptography, it took parts of peer-to-peer, it took parts of database, it took parts of all the other things and made one innovation that said, okay, now you have blockchain, and with this you have a glorified database that is accessible by everybody. So if somebody wants to know some information, you can very easily get access to that information, and we will examine how that happens. So at the very bottom, you would see that we are talking about hashing. And in terms of hashing, there is a variable sized input and there is a fixed size output. So what do we really mean by the variable sized input and fixed size output, right? So let's take a look at this. So each of these is a uh, block and all of them have some hashes. So let me switch to something that I would want to show you. Um, so I'm using this browser Brave. This also has some relation into blockchain. So pay per advertisement. So you basically don't have any internet ads that could come and be visible to you. So instead, you choose what kind of content you want to see. So you can definitely try out this browser. All platforms, it's available. Okay. Um, so I'll just type in the message, hello all from blockchain and cyber security. Okay, so you can see that while I'm tapping that, every word that I change, you can see the hash is changing below it. So what happens is the brilliance of it is this is the text that we enter and it is converting that into what is called as a hash. And in other words, a hash signature, meaning every time we type this very same word, so even blank has a meaning here. And if you see, the sentence that we typed has a meaning here, and you can place multiple sentences of this here, or even you could put entire Constitution of India and 1,000 libraries together, you would still get a fixed length value here. Okay, and this fixed length value is called a hash, and mathematically there are algorithms like SHA-256 that are taking care of creating this kind of a hash. So on any computer in this world, if you apply the same algorithm and do the hashing, you'll get the same output. Okay, this is one technology behind blockchain that needs to be understood, hashing. So why hashing is important? Say, for example, we are recording the data about vaccine number one uh, stored at 2 degrees centigrade. So, so the moment we entered that, that had a hash, right? So in this way, n number of vaccines, n number of people, n number of organizations doing transactions, they can all record their data in terms of these hashes, and you basically get a unique representation to them. So as long as it is just these two, the hash is going to be this. Okay, so just stay with me on this in terms of the hashing. So let's go to block. What do we mean by a block? So let's paste the same sentence here. And every block has a number and you still have the hash. So what did appear new here? So the one thing that appeared new here is the block number and the nonce. So nonce is nothing but it's a nonce variable, so to say. It has no meaning, but what it can do is it is going to variate itself in such a way that it results in a signed hash. Okay, what do we mean by a signed hash? If you see below, just remember this first four letters A1B5, and I click the word mine. Okay, and you can see that the first four letters have changed, and also the content has changed from red to green. Um, and these four letters are the first four digits starts with zeros, right? And you can also see that the word, I mean, the nonce value has changed from something else to 88747. Okay, now I change something here and say vaccine number 2 stored at 2.5 degrees centigrade. You can see that it immediately resulted in an unsigned hash, and whoever is validating it can easily detect that, okay, there is some change in terms of data. And unless they mine it again, it won't become a signed hash. Okay, I clicked on mine again. So now it became a signed hash. You can see the 4 zeros that appeared here. Okay, now let's go to the step further and see what, I mean, this is, if this is what is a block, then what is a blockchain? Right, so I have block number 1 and I have block number 2. Let's add one more vaccine in block number 2, vaccine number 3 stored at 2 degrees centigrade, and block number 3 stores some more information. And like that, there are more and more blocks, and each of them have started adding more information to each other. Okay, so what do I do? So I basically mine the first transaction, and I come back and I mine the second transaction. So just observe the word nonce here. So it's changed, and then I mine another transaction. Okay. So why is it a chain? So blocks 1, 2, and 3 are part of a chain now. Basically, if we start at block number 3 and look at the hash, there is one more variable that got introduced here called as a previous hash. So if you see, this is the hash value of the prior block that's here, right? And then this has a previous block, and that is the hash value of the first block. And if you notice, the first block does not have any previous hash. Okay, it's all zeros, and this is what is called as genesis block. Okay, the first block of any blockchain is called genesis block. And the reason why we use the mine, I'll explain it to you a little bit. But what is mine doing is it is looking at what are the variable that can take this exact text, combine it with this value of nonce, and then result in a signed hash. So what can it do? So there are various data components here, right? The block number is here, the nonce is here, data itself is here, and a previous hash is here. So how do I combine all of this to result in a signed hash is what happens when I click on mine. And if prior to us clicking mine, everything was red and then it turned green. And if you can notice, you can keep doing this and all the hashes will get linked together from one block to another block. Okay, so that's how, let's say the example that we are taking, all our vaccines are getting recorded. And let's say, just for sample, I change something here. Okay, you could see all three blocks went red. Okay, why? Some data has changed here, and that data, uh, unless we mine that block and the next block and the next block, it does not result in a proper blockchain. Okay, unless everybody gets linked together, it does not result in a proper blockchain, meaning a signed chain. Okay, so let me just take an example of distributed also. And then maybe if you have any questions, we can talk about that at the time. I see some questions are coming across. So let's just take the example of distributed here. Okay, I'll take the exact same copies. For somebody who is asking how is the nonce value calculated, it's a mathematical algorithm that runs behind. And once you click on mine, that algorithm calculates what is the variable behind it. Okay, and in other words, these are people who are called as miners, and this is also called as proof of work. So to just to prove that yes, I did some work to be able to be part of this blockchain. Now, in case of distributed blockchain, like we were discussing, blockchain's major advantage is this data you can store anywhere. Vaccine number one is this much, and vaccine number two or vaccine number four is certain amount. It can be stored anywhere. Let's say, for example, this is your traditional database, and a lot of people have access to this database with right access. And let's say somebody goes and changes the value here from 2 degrees centigrade to 3 degrees centigrade, right? And then expose the information. So all your systems will think that the vaccine number 2 is stored at 3 degrees centigrade, whereas it was originally at 2.5. Okay. So if it is a traditional database, what will happen? At only one place, information is stored, and anybody who has access to edit that data is able to edit that data. Now let's see how it is different in case of blockchain. Okay, I mined block number one, block number two, and I'm going to mine block number three. Okay, what happens is, if you can see the words here, there is a peer A, there is a peer B, and there is a peer C. What will happen is they'll all start sharing this blockchain. Okay, and the way they can share this blockchain is in this way. They all have a mechanism through which they communicate what is the latest chain and what is the information that is stored on the chain. And I'm just going to use two peers here, while you can have n number of peers. So let's just take a look at these two peers. Okay, and then try to compare what is it different between these two. Okay, if you notice, each of them has a copy of this block, and basically each of them can have can have this stored in such a way that they are able to validate what is the hash that results in it. So in this way, as long as data is the same and hash is the same, nobody needs to really validate whether the data is original or not. If all of them have shared same copy of this data, if you can notice, this particular block hash is same as this particular block hash. And like I mentioned earlier, every time you run the short-of-thesis algorithm to calculate this hash, you are able to validate that yes, it is the data that is signed, and that sign results in the same hash. Okay. So if you see nonce values, these are also same. So if you can recognize, all of this information is identical. So in this way, everybody, peer A, peer B, peer C, all of them, they are basically sharing this chain between themselves. And let's say peer A got malicious and said, okay, now I want vaccine number three's temperature to 3 degrees. Okay. And then I'm going to mine it myself and pretend that everything remained the same. Okay. But then what happens, this chain, when it gets compared with others, if you can see this hash 00002DD5 or 45 is not the same as 0000 and BFAE. And it continued on to any number of chains from where the transaction got altered. Okay. Now, can somebody cheat this kind of a system? No, right? So the more, what is the advantage? If I just have two pairs, what can happen is they both can talk to each other and say, hey, I'm going to change my vaccine number 3 to 3. You also change your vaccine number to 3 and then mine it. And then we both will be equal, right? So in that way, people can cheat the system. So the more number of pairs that you have, the more number of copies that you have that are spread across, the more advantages you have in terms of a blockchain solution. Otherwise, all of this data, you can still store it on a central database, but what happens if the data gets tampered? Okay. Now, as you can see, blockchain, one attribute that people associate with blockchain is immutability. So what is immutability? Nobody can change. But as you can see here, peer A was able to change the data. But unless all the other peers can validate that it is an authentic copy, it's not an authentic copy, right? So in this way, blockchain is basically protecting your information in such a way that what was stored originally remains the same over a period of time. Okay, so that's what is about blockchain and a simple example in this context. So the more complex ones you can examine from this website. I'm going to share this link with you all the resources I'll be sharing after this session. So this is a token. Okay. Now, as you can see, a blockchain's data can be used to store any kind of a data. We used it to, purposefully used it for vaccine data because this is not money you are storing here. This is data about what temperature your vaccine is stored at. So what happens over a period of time is this data gets accumulated and accumulated, and we just start talking about 3 blocks in a matter of 1 minute or 2 minutes. But really, in today's real world, if you see Bitcoin or Ethereum or any of these blockchain platforms, what is number 3 is called as a block height. Okay, and their block height today is in hundreds of thousands. Okay, and the data they are storing is more than 200 GB in size. Okay, so that information is percolated to everybody and anybody around the world. Okay, and the decisioning using which these guys are able to come to a conclusion that yes, all this data is matching with mine is called consensus. Okay, consensus says that any decision that is taken in the network is propagated to others, and all of them agree that yes, this is the correct information that we all agreed upon. Okay. Um, so let's see. Let's just take a quick pause here, maybe a couple of minutes just to answer a question or two, because we also need to meet the timeline that we have. So any questions so far? And Varun, if you can please read it out. I'm not able to see the questions. Okay, I can see them. Standard algorithm to calculate hash value is SHA-256. What's the difference between SHA-256 and block hash? Shailendra asked this. So basically, block hash is basically the same thing as your SHA-256. SHA-256 is your algorithm. It's not like a data or business entity by itself. SHA-256 is the algorithm. So this SHA-256 hash that you saw here is the same thing in terms of data. Okay, so that's what it is. But the difference here in terms of any block number 1, block number 2 is you look for a signed hash. Okay, so here something has changed. That's why it's not the same. But basically, you are looking at signed hashes in case of a blockchain. If you are simply hashing is a technique that existed even before blockchain existed. And if you can see OS downloads for Ubuntu or any open source software downloads, they keep a checksum. A checksum is the hash that was calculated with the executable content, and say that if you are once you download, you can calculate the checksum for what you downloaded, and if it does not result in this particular hash, then you have a duplicate copy of our then you have a illegitimate copy of our software. That's what they would be saying. Okay, so those are a couple of questions. Maybe we could get answers. Okay, somebody asked what's the difference between a signed hash and unsigned hash. So okay, let me show you something. So I manipulated vaccine number 3 to store at 4 degrees centigrade. And you can see the first 4 digits don't start with zeros. Okay, this is an unsigned hash. But once I click mine, it becomes a signed hash. It gets zeros. And how is it getting zeros? The variable here is the nonce. Nonce is basically calculated to check whether first 4 zeros are zero. What is the combination of all of this data with the nonce value, so that it can, I mean, this is and like I said, this is a nonsense number. This has no real use except that it can make a hash as signed. Okay. So yeah, but either way, so that's what is signed and unhashed. So let me try to move on with the rest of our presentation. Can we get the information slash data of block 1 from block 3? Is Yeah, you can, I mean, you need not say that every block has a copy of everything that was there behind. You have a chain of data that's there. So, so it need not always, okay, the example might have misled you. It need not always be the case that we take all the data from the first block and put it into the second block. Yeah, I mean, as such, second block can store just this, and fourth block can just store this. I was just showing you for example purpose. I mean, it should not have misled you, but basically, these data, you are not exactly copying all the data to all the blocks. So that's what is a chain of data for. So each of this block carries different transactions that existed. And if you play with this tokens demo that is there here, you can see that different people transfer different amounts of money to different others, and that's what is tokens. Okay. We just have half an hour more left, so let's try to come back to the presentation. 1 second. Okay. So now I hope we understand what does it mean by distributed in terms of blockchain. I hope we now understand what do we mean by signed and unsigned hashing, and what does it mean by Genesis block, and what does it mean by provenance and encryption. Okay, these are two things that we haven't talked. So encryption, as you may all know, is if we use a word that is to be encrypted, for example, if you take Rishi and right shift it, for R you replace it with S, okay, and every word you replace it with the next subsequent letter, you would get a string there, right? So this is the simplest of forms of encryption. That means whenever you send this message or my name to somebody else, you would not you would not recognize it immediately, but with a little bit of automation, you can easily crack the code saying that this is a right shift of data that happened here. So in a way, this is encryption, and there are so many different types of encryption, RSA, DES, and so on and so forth. But in case of blockchain, this encryption is also used behind the scenes to make sure whether the person who is sending the data is really the person sending the data or not. So this is called signing. And once I am able to send the data and sign it, I can do that by using certificates. So there are asymmetric and symmetric types of certificates. So in interest of not to make this a cryptography oriented session, we are not covering a lot of detail about cryptography here, but encryption also forms the basis of how blockchain takes care of various things, right? And provenance is a word that we haven't used, but we have seen that vaccine number 1 went through a series of changes in terms of data, and as and when it recorded a temperature using a sensor or certain other aspects, it could easily be tracked as to what are the various temperatures at which this particular vaccine number one is recorded. So in that way, provenance is tracking. I mean, the ability of tracking to the source or into the origin. So that's what is provenance. And like I said, we talked about proof of work and proof of stake. So proof of work and proof of stake, these are consensus algorithms. Proof of work says that you need to prove that you did some amount of work. In this case of what example that we looked at, you need to prove that it's a nonce value that you calculated. It might not have looked that difficult, but behind the scenes, the algorithms that run to mine the transaction, the more complex data that you have, the more amount of time it takes to calculate the nonce value and identify to come there. Okay. So in proof of work, there are these people called miners, or these are computers basically to mine the data that is coming in and all the transactions that are coming, and that all those transactions are kept into a block, and then that block is given a hash, a signed hash. So for that block to arrive at a signed hash, there are certain number of calculations that are supposed to happen, all these nonces that are supposed to be calculated, and it takes certain amount of time. So proof of work is where n number of people compete to identify and arrive at that nonce value and prove that that is the correct nonce value, for which whoever did that first, okay, remember this, whoever did this first will get the reward in proof of work. And rest all, let's say 100 people competed but only one met the time, then only the first person who came with the answer is rewarded. Okay. um, okay, so they are rewarded. So the proof, that's what is about proof of work. And proof of stake is more about, let's say there are 10 people in the room, all of them have different amount of money with them. So somebody who has a certain amount of money puts their money as security and says, okay, I want to participate in the transactions. And the more money they put into the security, the more control they get. Okay. But this way of doing the consensus and giving weight to them based on the money is not really encouraging democracy. So proof of stake without giving equality is not a good thing. So that's why proof of stake algorithms, though they existed, I mean, most prevalently used algorithm today is proof of work. And there are hundreds of other types of algorithms like proof of elapsed time, um, proof of n number. You can say any number of things. You can just Google proof of work, proof of something. Then you'll hear at least 30 to 40 algorithms that are saying, okay, we all provide this consensus. Okay, Bitcoin uses proof of work. Ethereum uses proof of work. So these are the two common blockchain platforms that use consensus. So that's what is about consensus. Okay. Um, So we covered what is a block and what is a hash. Why is it called a chain? A series of blocks linked together, basically. So we are going to cover what is a permission and public blockchain. Um, what is proof of work we talk, why decentralization, what are various decentralization technologies available, is blockchain a better choice? I think by now you would have been thinking about, okay, should I use blockchain or should I use my traditional database for storing my transactions? And ideally the answer should be don't use blockchain unless you have a certain need for it. So we'll cover a few more slides about that in terms of the perspective that you need to get. So let me also um, about the types of distributed ledgers that are there. Okay. So there are various types of distributed ledgers that are there. And I mean, you can replace the word distributed ledger with blockchain, but it would not match with certain aspects. Like, for example, Ethereum and Bitcoin, both of them use blockchain and they use the linear structures like I've just showed you in terms of block number 1, 2, 3, 4, and 5. Whereas IOTA, it uses some cyclic graph. So it's more of a graph structure kind of a thing. And it basically enables distributed ledger, but not through blockchain. So through a structure called Tangle. Okay. So what you see here, Ethereum, Bitcoin, and IOTA, all of them fall into what is known as public and permissionless quadrant. Okay. There is public and permission. So where Ethereum Enterprise Alliance and Ripple are there. There is permission and private, which is where Hyperledger Fabric and JP Morgan and Zcash, all these algorithms are there. There is nothing called as permissionless and private, because if it is private, you cannot have it permissionless. So permissionless, the primary dependency is on public. Okay, let's take a few more perspectives about this as to what the same quadrants means in different worlds. So the most commercial blockchains prefer to use permission blockchains. So in other words, organizations today are preferring permission and private blockchains predominantly because if the data is not encrypted and it's there on a public network, like for example, the vaccine example that we talked. So in terms of vaccine storage of data, all the customers want to know that information, have easy access to that information. But imagine instead of vaccine data, we are storing trade secrets, right? So in that case, what happens is your data confidentiality is lost. So in these cases, commercial enterprises want to use permissioned blockchains. And in other words, let's say Audi, Maruti, BMW, all these automobile companies come together and want to say all the parts that we manufacture, we want to be easily traced and we want to do a blockchain solution. What they can do is they form a consortium. And today there are consortiums like that that exist in the name of Mobi and other initiatives that are there. In the shipping industry, Maersk is doing something. So we talk about these use cases a bit later. But commercially, if you see the blockchain architecture options that you have, on the left-hand side, you see the public and private architecture based on ownership of data. And on the top, you see architecture based on read, write, and commit permissions granted to participants. So public and permissionless, anyone can join, read, write, and host it on public servers. It is anonymous and highly resilient, and there is low scalability. And in case of permission and public, anyone can join and read, but only authorized scalability. Why we're talking about scalability in this case is uh, because of the time it takes to all the consensus that needs to come across in terms of thousands of nodes that are there in the world, the transaction times are slow. Ethereum and Bitcoin, they're trying to address this using concepts like sharding. So what happens in case of permission days, because the number of people who can write and commit the transactions are less, the scalability increases, right? And if you can see, private and permissionless, only authorized participants can join, and it is hosted on private servers. So in this way, what happens is you don't, you basically have a high amount of scalability, but it is hosted on private servers. So since only authorized people can join, there is it is within the bounds of an organization and within the host, within the network of certain people. So what is private and permission? Only authorized participants can join, and only the network operator can write and commit. So in this way, what happens is the various types of architectures that you choose make a difference in terms of private, permission, and permissionless combinations. So the best combination is permissioned for organizations which are commercial in nature. Even if it is in terms of governments, data that can be read by everybody can be exposed easily, and only certain people are able to read and write. So that may be the kind of data governments wants to choose. Okay, so this is another viewpoint in terms of anonymity of the validators and the trust in validators. So the anonymity of the validators goes higher once you go to public, and once you start going to private, you need to know who these people are. Otherwise, you cannot give them permissions, right? So in this case, the anonymity reduces. Trust in validators is less in permissionless and high in permission, because you know who they are. Then the trust in validator is high. So there are these two parameters based on which a lot of things keep happening in the blockchain world. And you can see permissionless public and public and permission private and permissionless private. Okay, so there is permissionless private, not many people use it, but all the other combinations, there are a lot of organizations that use it. So tomorrow, what we are going to talk about in terms of Hyperledger and the hands-on sessions, there we can discuss a bit more in terms of permission networks. And even in context of cyber security, permission is the best implemented, because you everybody in the outside world without a proper permission. So otherwise, you don't meet the confidentiality attribute. Okay, so then I think we should be able to go through the use cases that we are talking about. Okay, so what we talked about earlier, the plain simple analogy of blocks 1, 2, 3, 4, and 5, all of them coming together. Uh, so what happens is, the more number of nodes that you have, the more number of people who have malicious intent. What happens is they will also start having subblocks or subchains. So what you see here as pink, it's the genesis block, and blue is what is the original chain that is going to continue. Okay, now you can see these oranges now and here, now and there. What are these oranges? Okay, and why blue one? Okay, so this orange happened, and this is a transaction like where we said vaccine number 3 has 3 degrees of temperature. Nobody agreed to that, and it remained as an orphan. Then in terms of blue, what happened is transactions are continuing and continuing. So there is one more orphan that happened here, and somebody believed in that data and then added one more block there, but that's all. Okay. And then the blue chain continued and went further. And again, there is one more change that happened here. And somebody tried to mislead the blocks. And here also blue one. Okay, usually there are logics in each of these blockchain protocols which say longest chain wins. Okay, what that means is wherever most of the nodes are putting their transactions and approving those transactions, that chain is considered as authentic and genuine. Okay, there are fail-safe mechanisms and full proofs that are built into the protocol itself to basically enable this kind of mechanism. Okay, and then in context of Bitcoin, there is something called as an uncle, because it would be considered as an orphan, and it is not on the longest chain. So in other ways, these orange blocks are also considered uncles. Okay, and whenever multiple paths are generated, a fork occurs. Okay, a fork, the difference between an orphan and a fork is a lot of the nodes of the network believe in the fork and try to continue that. But and the protocol definitions that are kept within the software that governs these blockchains, these folks cannot continue for a long time, and they have certain amount of approval rates that are coming from within the network. So that's what are uncles and forks. So why we are talking about these? These are concepts that are underlying in terms of your blockchain, and these are things that you keep hearing. What is a fork? What is an uncle? So tomorrow somebody will say, okay, Bitcoin blockchain, the result fork. and they are implementing multi-signature feature. Okay, so because of a feature, and that at that point of time, what happens is you cannot go back and use the old software. You need to continue using the new software that was built. So all the existing transactions are consolidated and then moved on into the new chain, and that's what is a fork. Okay, so not every orphan is a fork, but a fork is where you have more number of nodes that are coming into picture and saying, yeah, these blocks are valid. Okay, so then one more thing that you keep hearing in the blockchain world is about Oracle. Okay, what do we really mean by Oracle? So blockchains use this programming called as smart contracts, and these smart contracts can access data on the blockchain very easily because they are programs that reside on the blockchain in some way. And in best case, you can implement smart contracts is about Ethereum, which anyway is the next session, and I think you'll see some smart contracts there. But basically, here we are talking about how do we access off-chain data? Okay, let's say, for example, there is somebody who have bet, okay, whether BJP will win in 2024 elections or not. Okay, let's say there is a bet. Now on blockchain, this information is not available, and when it happens in 2024, that whether that particular bet has been won or not, blockchain itself will not know. Okay, so this data comes from off chain, and how do we make sure that data coming from off chain is trusted? So you need to have a trusted source outside of your blockchain. So in a way, this is an integration that you are building from your outside world into blockchain to have information that is coming from different sources. Now, even in the case of vaccine example that we are talking about, the hardware or the device that is measuring the temperature itself is not on blockchain. Okay, but it can access blockchain, or it can trigger or publish the data to a certain place where data could be accessed by blockchain. So in a way, we established an oracle in there. Okay, so it's not really a complicated thing. The easy way to remember about oracle is at any point of time you want to access off-chain data that's not there on blockchain, you do it through an oracle. Okay, so they link between off-chain and on-chain data. Now, data that can be transmitted by oracles can come in many forms in terms of which source it is coming from, whether the data is whether the data will be originating from software or hardware, whether the data is coming in, or whether blockchain is publishing to somewhere which is outbound, and the amount of trust we have in it. Is that particular oracle centralized or decentralized? Okay, another example that you can take about Oracle is the stock quotes. Okay, a stock value is something that happens in real world in terms of your stock market. That's not happening on blockchain. But let's say BSC gives you a link or an integration to validate what does the share cost of Reliance mean in here. So maybe in that case, you can use an Oracle to access that kind of a data. Okay. So in other words, why is blockchain immutable? So blockchain's immutability comes from what you can say as consensus. And we talked about this already. One second, guys. No noise that's coming from behind. Um, so all of these blockchains that we are talking about here use. Okay, sorry. So all of these blockchains that have been coming are using this concept called as Merkle tree. Okay, so Merkle tree, the importance of a Merkle tree, to put it very simply, is you saw block number 1, block number 2, block number 3, and block number 4, right? So each of them are part of what is called as a block header. Okay, previous hash there is a nonce. Okay, but every transaction to be identified individually has a hash of its own. So here, if you can see, there's a transaction number 100 which has a hash of 100. Transaction number 101 has a hash of 101. So in this way, you have multiple hashes linking together. Transaction number 1 and 2 have got a hash together, and that combined with another tree resulted in the root hash. So in this way, what happens is all your transactions will basically converge into tree structure, and the top one is called as a root of the tree, and this is a branch in terms of what's there in the middle, and each transaction is a node. So why do you need Merkle trees? Because tomorrow if you want to validate whether vaccine number 4 has 3 degrees centigrade or 2 degrees centigrade, you need to be able to recognize that transaction onto the chain which already has hundreds and thousands of blocks that are already there. So in this way, what happens is your the Merkle tree that is there helps you identify where your transaction is there. So the algorithms that implement identify the root hash and then go to the where exactly the transaction is going to be there. So in that way, between hundreds of blocks, you'll be able to spot which block has the transaction that is related to my vaccine number 4. Okay. So this is what is about Merkle trees. Okay, by now you would have been thinking that, okay, maybe blockchain is a very good system and it's an innovation that everyone can use for every kind of a problem. Okay, and that's where we need to be very careful. So blockchain will come with its own burden, and to be able to to be able to benefit from it, we need to make sure that we follow certain decision trees. What you see here in terms of the picture is one of a decision tree, and one of the most common reasons that you see people blockchain using blockchain today is because it is immutable, and you reduce the number of intermediaries that are there. In this decision tree, what is being asked is there a need for a shared common database? Because that's what is blockchain about. Only if the answer is yes, then you go forward. Are there multiple parties involved? Only if the answer is yes, then you go to the next stage. Okay, so we always need to put the inclination for innovation on one side, and whether we really need to use this kind of a system on the other side. So blockchain is not really a silver bullet that we need to use for every kind of a problem that is there. Okay, and it all depends on what is the business problem. Only then use blockchain. And that's what we could say with caution about blockchain. So there are several use cases that are there. Walmart is using it to trace all its vegetables, whether it's, where these vegetables are coming from, which particular farm they came from, to be able to identify that. And at some point of time, back in 2016, Walmart faced a problem that a particular strain of lettuce that they were selling in the stores was carrying a bacteria or a viral infection, and they had to identify where it came from. They were not able to identify, and what they did is across all the Walmart stores in the United States, they have thrown all the produce that is there from lettuce. And it is, of course, it might not look like a dollar or two lettuce is not going to cost much, but imagine across all the stores of 1,500, and you have so much of product, the result of loss would be in millions of dollars. So what they did is they implemented it in such a way that they could identify each lettuce bunch that they are selling through the barcode, and all the suppliers who are supplying them, whether it is lettuce or another type of vegetable, to put their data onto blockchain. And that data, once it is there on blockchain, it is easily identifiable as to where it came from. That way, they don't have to throw away each piece of lettuce there is, and then use that data. Maersk is using this for TradeLens platform to ship all the containers that they have. And in terms of shipping lines, if you see the example of I mean, even in, I mean, for people, those of you here from Vizag or any port city, you see that ships are lined up outside the port, and they have been there for weeks together or sometimes months together, right? So at any point of time, just like you have taken a rental cab and gone somewhere, you just keep it in parking, but you still keep paying the bill. That's a lot of loss for shipping companies. Okay, and most reasons why these ships wait outside the ports is because of unclear papers, customs documents, and all of that. So, what if that could be digitized and shared across all the ports in the world? And that's what is TradeLens by Musk. So, like this, there are several implementations that are talking about using blockchain. But if you see, part of the problem is digitization. Even if you take the example of Walmart, or even if you take the example of Mars, in both cases, there was no digital system that existed before to make sure all of this data could be shared. Okay, so when they are solving the problem of digital, they also added blockchain to it so that all the ports in the world could share that data. All the Walmarts across the United States, they could share that data. So part problems are digitization, part problems are related to how do we share this data in a way that it is not corrupted. So that's where blockchain comes into picture and helps solve problems like this. So banks are using this, diamond companies are using this, stock exchanges are using this in different ways. Okay, with 2021, the implementations that have been using blockchain have seen a surge in terms of 2020. So there are a lot of organizations that are getting onto blockchain to make sure that people trust the data that is coming from blockchain. So with that said, that's what is about today in terms of blockchain. Let me just take you all back to the questions checkpoint again. And I believe there is a quiz kind of a thing that the team has set up, and you could try and answer that. But I believe most of these questions that you have now are answered. So we learned about what is a block, what is a hash, and what is blockchain. We learned about difference between permission and public blockchains. We learned about what is proof of work and why do we need decentralization, and what are various decentralization technologies available, and whether to make the choice of blockchain, whether it is a better choice or not, and of course the relation between cybersecurity and blockchain. So these are all the things that we have talked about. And for those of you who have an inclination to do some hands-on, tomorrow there is one more session that we are doing related to Hyperledger. And today, following up to this session, there is a session on Ethereum. So I believe you would get to do some hands-on in these sessions. So for tomorrow, if you would like to participate on the hands-on or maybe want to follow through after this session, then you can install this software, and these slides will be shared with the organizers and they'll share them with you internally, and you could access them. So all the resources that you can go through, all the software that you can install, we'll be sharing that with you people, so you can install these. So VS Code and Hyperledger, because tomorrow's Hyper session would be about Hyperledger. All of them have a dependency on Docker, Node.js, Go, and Java. So at least Node.js and Go you would need, and Hyperledger. So the instructions are clearly mentioned on the website link that I'm going to share from Hyperledger itself. So you could use that and basically get ready for some hands-on. With that, we are at 10:30. I really thank Vali Madam and the and Srinivas Raju and the team behind this program to give the opportunity to share this knowledge with you all. And let us see if you have any questions and how much time we have for questions. Let me pass pass the moderation back to Varun. So you can type in any questions that you have in chat. I'll be here for a little bit, and then I have some office calls to attend to. Varun, can you hear me? Yeah. Is this Rashmi?
Yeah. Rishi, am I audible?
Yeah, you're audible, ma'am.
Yeah. Okay. Thank you, Rishi. Uh, Dear participants, hope session was useful to you and it gave what is blockchain technology. So, yeah, we'll share the material with you. So we have a Google Drive, a link that will be shared at the end of today's sessions, wherein you'll have all the material that the speakers wanted to share with you. And now let us have a 10-minute break, after which you will be having a quiz. Okay. So be back with your smartphones and laptops, and we'll start the quiz exactly 10 minutes from now. Uh, so have some tea, go around your house, relax for a while, and then after the quiz, we'll have V. Srinivasaraju. Okay, so
Thank you, ma'am.
Sandeep.
Hello, everyone. So the link has been pasted in the group chat. Please go through it. If you want, you can download the app too. If you go through the www.kahoot.it, just enter the game pin only on mobile phones. You will be able to see the questions on our screen, on my screen, on laptop screen, and you have to answer on your mobile screens. I repeat, the questions will be visible on the screen which you're seeing right now, and the answers you have to answer in your phone.
Hello, everyone. Hope you're all back. Now we'll conduct the quiz for the first session. So the quiz questions will be displayed on your screen that you're seeing right now. And you have the app nearby. You need to follow these instructions. So Varun will guide you through the process and we'll start the quiz soon.
So now, shall we start the game? So this is a game-based quiz. As you know, we are all migrating towards online education, a paradigm shift from classroom teaching to pure online. We are in the middle. Or rather, to tell you, we have just begun. So now we start the quiz. Please on board to the quiz first. You'll see a set of questions on the screen. Okay, and you have to type the appropriate color code on your mobile. Hope you understood. Okay, so if someone Nana Mayuri says wait ma'am, so we'll wait for her. So we have about 250 participants till now, of whom 149 have started playing. So we'll wait for some more time. If you still want us to wait, type in the chat window. If there are no more players to join, we'll start the quiz. Shall we start the quiz? Type in the chat window. Okay. Okay. So, yes. Now we lock the quiz so that no participants disturb us in the middle. We have locked. We proceed. Start. Question. What does P2P stand for? Password to password, peer to peer, product to product, private key to public key. You have to type on the color code on the app. Red for password to password, peer to peer, blue, yellow for product to product, green for private key to public. 37, 38, 45 answers. Very good. 58 seconds to go. 77 answers. Very nice. And remember, fastest finger first. The one who actually types the correct answer first will have more points than the others who have typed in the correct answer. One 33 answers, 16 seconds to go. Time's up. Right answer, peer-to-peer network. 61 people have answered it right. Okay. So, shall we move in for the next question? Get ready. Next. Yeah, and Aruna has stopped in the first question. She scores 958. Satyakirti follows her with 952. And then on board are Nana Mayuri, Sri Krishna, and Ram. Congratulations. Next. What is a node? And the questions are a type of cryptocurrency, a blockchain, a computer on a blockchain network, an exchange. Red for cryptocurrency, blue for blockchain, yellow for computer on a blockchain network, and green for an exchange. 73 answers, 64 seconds to go. Very good. 110 answers, 2 seconds to go. Moving slow now. On the chat box, don't type on the chat box. Go to app, go to app in your mobile phone and then click on the color code. Okay. Please don't type in the chat window of WebEx. Type in Kahoot app. Someone is unable to connect. Okay, keep trying. It may be a problem with your internet. Very good. 93 people have answered it right. A computer on a blockchain network. And let us see who wins at the end of the second question. Satyakirti has stopped and Nana Mayuri follows with 1984. Sri Krishna is at third position with 1972 points. And then Bhaskar and Preeti are at fourth and fifth positions. Congratulations. So Himaja is the highest climber with 4 points. Who created Bitcoin? Third question. The answers are Satoshi Nakamoto, Samson, John McAfee, and China. Select the appropriate color code. 95 answers in 64 seconds. 64 seconds to go. 180 answers. 50 seconds to go. Remember, if you type it fast, you get high score. But then if you type a wrong answer, you lose a lot of points. You have to optimize. 30 seconds to go. 10 seconds to go. Still 20 more people to answer. 25 people more to answer. 5, 4, 3, 2, 1. 111 people answered it right. Very nice. Let us see who are on the podium. Satyakirti retains his position with 3,179 points. Nana Mayuri follows with 3,153 points. Bhaskar has 3,124. Pavitra and Sindhu, they follow. So 3 ladies out of 5 on the podium. Wow. Next question, what is a blockchain? A distributed ledger on a peer-to-peer network, a type of cryptocurrency, an exchange, a centralized ledger. Come on, quick. $75 answers, 72 seconds to go. $55 seconds to go. Still 50 more people to answer. Do it fast. Yeah, someone says game is locked. Yes, we have given you enough time to join the game. You can try it out for the next session. $30 people to answer. 15 seconds left. Come on up, participants. 5 seconds to go. 4, 3, 2, 1. 99 people say it right. A distributed ledger on a peer-to-peer network. Good. And Satyakirti remains on the top. Bhaskar follows with 4398 points. Sindhu holds a third position with 4367. Tarun with 4340 points. And Krishna at 4336 points. Fifth question, what is a miner? A type of blockchain, an algorithm that predicts the next part of the chain, a person doing calculations to verify a transaction, computers that validate and process blockchain transactions. $82 answers. 55 seconds to go. A type of blockchain or an algorithm that predicts the next part of the chain, or a person doing calculations to verify a transaction, computers that validate and process blockchain transactions. Come on, 30 people to answer. 11, 10 seconds to go. Come on, participants. Nothing wrong if you type a wrong answer. Do an appropriate guess. 59 people say it right. So less than half. Computers? Yeah. And Bhaskar now comes up fast. To top the board, 5754 points. Next question, what is a dApp. A type of cryptocurrency, a containment, a type of blockchain, a decentralized application. What is a dApp? Of crypto condiment, a type of blockchain, a decentralized application. 100 answers. Seconds to go. Thirty people to answer. 20. 20. 10 seconds to go. 2, 1. 110 people answer it right. A decentralized application. Let us see who tops the board. Bhaskar scores 7,106 points, followed by Madhu, Syed, Sandeep Verma, Sri Krishna. Very nice. 7th question. What is the term for when a blockchain splits? A fork, a merger, a side chain, a division. 39 answers. Or when a blockchain, a fork, a merger, chain, a division. So may chat window. You're a kind of leaking the answer. Fell from the group. Is it Somesh from GMS? A fork, a merger, a side chain, a division. Twenty seconds to go. 40 people to answer. Four, 3, 2, 1. 88 people answer it right. A fork. Next. Who tops the board? Madhu tops the board. Syed follows with 8,568 points. Sri Krishna, Ram Prasad, and Nidhi. Third, fourth, and fifth questions. Next. 8th question. What is the purpose of a nonce? Follow now. Function to the blockchain network. Answers already. What is the purpose of a nonce? Follow now. Function prevents double spending, sends information to the blockchain network. So someone types not join the quiz. You have to be on time. answer. Purpose of four, three, two. So 28 people answer it right. Prevents double spending. Let us see. Nidhi tops the poll, 9,911 points. Amita Goel follows with 8,616 points. Madhu, Sai, and Krishna still are on the board at the third, fourth, and fifth positions. Next, ninth question. One more question to go. Correct validation of trans. Announce a block reward comes up from the community, more memory. I repeat, what incentivizes the miners to give correct validation of transactions? 77 answers, 80 answers, 40 seconds to miners to validation and answer from the community, more memory. 50 more people should answer. Friends, at least guess. You know you have to answer it fast, otherwise guess. Time up. 77 people answer a block reward, which is the correct answer. Next. So who tops the scoreboard? Nidhi retains the position with 11,320 points. Amita Goel follows with 10,025 points, and Madhu, Syed, and Ram Prasad share third, fourth, and fifth positions. Congratulations. Next. The last is the first block of a blockchain, famous block that hard-coded a block of Genesis onto the blockchain. The first block after each block having the second transaction of a blockchain. What is a Genesis block? Block of a blockchain, famous block that hard-coded a hash of the book of Genesis to the blockchain. The first block after each block halving. The second transaction. 1 or 3 answers. 50 more people to go. 40, 42, 41, and 40 seconds to go. What is a Genesis block? Thirty more people to fast. Only 10 seconds to go. 4, 3, 2, 1. 99 people answer it right. The first block of a blockchain. So let us see who are the toppers for the first stage question. Madhu Bhati, third position. Amita Goel, also second position. And
These singer tops the quiz. Congratulations. And runner-ups are Syed. Congratulations, everyone. Have a 5-minute break so that you'll get back to the WebEx sessions and we start our sessions. Mr. Srinivas Raju is already with us. So I request Lasya to take over and introduce. So meanwhile, take a 5-minute break to. Thank you.
Thank you, ma'am. Welcome back, everyone. This is Lasya, a computer science student from AUCE. Coming up now, ladies and gentlemen, is another enlightening session on Introduction to Ethereum Ecosystem Public Blockchain by Mr. Srinivasa Raju V. Mr. Srinivasa Raju is a determined and a passionate software developer with more than 7 years of experience in developing scalable and multi-tenant distributed cloud applications. He worked in academia for more than a decade and is also a certified ethical hacker from EC Council USA. His passion towards building teams and handling projects on next-gen technologies is what inspires many people. It's a pleasure to have you here, sir. I now request Mr. Srinivasa Raju to formally begin the session. Thank you.
Hello. 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 Madam. I'm ready. హలో హలో
శ్రీనివాస్ రాజు, మీరు ఏ నేమ్ తో జాయిన్ అయ్యారు ఇక్కడ? ట్రైన్ టు యాడ్.
ఓకే, అదే అటెండెన్స్ లింక్.
యా యా, కాదు, ఇక్కడ నేమ్ ఏంటి లిస్ట్ లో? వాట్ ఇస్ నేమ్?
శ్రీనివాసరాజు అని అంటుంది. హలో సరే మేడం, యా షూర్. ఒక్క నిమిషం ఉండికి స్టార్ట్ అయితే తీసుకెళ్ళి
They can split it. Can you hear me, Srinivas Raju? Srinivas Raju, can you hear me now? Hello. Srinivas Raju, will you speak for a while? I think audio is good on your side.
No.
Yeah, Srinivas Raju. Now you can listen.
అవునండి. Yeah, వినిపిస్తుంది.
So there is some issue with Ubuntu and WebEx. we learned something. Yeah. So ఇప్పుడు మీరు how will you share the presentation?
Okay.
So I'm trying out some other option.
అంటే హ్యాండ్స్ ఆన్ చేయాలంటే మళ్ళీ నా సిస్టమ్ ఇష్యూ ఉండాలి కదా.
Yeah, that's what. అదే we are trying to put giving you highest privilege first.
అంటే యాక్చువల్గా అటెండీగా జాయిన్ అవుతున్నాను కానీ ప్యానల్గా అలో చేయట్లేదు అంటారా?
Yeah, Srinivas Raju.
Okay.
I think still there is some problem. WebEx is not recognizing your operating. Some issue there.
Oh.
Okay. Tomorrow and day after we'll try to split your session and accommodate during the time. Okay.
Okay.
So it's not good to make many participants, lose their time here waiting for us.
Sure.
So dear participants, so hope you have had a good session today. So we'll host Srinivas Raju's talk tomorrow and day after, and we'll try to not skip this session, but over 2-3 days, so that you still get the content of. Well, if you have any Q&A, you can actually interact with Srinivas Raju. You can type in the chat window, or so he is a blockchain expert. So to my knowledge, he must have trained not less than 1,000 people or more. I do not know. 1,000 people until now on blockchain. He's been into it for the past 5 to 6 years. So maybe he just started listening about blockchain. He's already an expert into it, and he has provided a lot of consultancy services in India and abroad. So if you have got any specific research or certain questions in particular, practical questions, you can post them here, raise your hand or unmute yourself and ask Mr. Srinivas. So So we'll close the session in 5-10 minutes after the questioning is over. We'll postpone this talk. Any questions? Srinivas?
Hello.
Yeah, there is a question. How to? So Nitin Singer is one of the participants asking a question.
Hello.
Yeah,
Madam, can you repeat the question? I didn't.
yes. Nitin Singer, one of the participants, is asking a question. How to integrate blockchain with cloud?
Okay. Yeah. Actually, most of the blockchain frameworks, uh, they are using the mining or the miners. They are establishing in cloud only. Right? So now lot of companies like Amazon, Azure, and Microsoft has come up with lot of blockchain frameworks, so which make you easy to establish a blockchain network within cloud. So anyhow, we'll be explaining about that one or two use cases how cloud companies are helping us to establish blockchain on the cloud platforms.
Okay. Is that okay, Nidhi? You can type in the chat window. Yeah, any more questions? Any more questions? Okay. Another question, if we want to store hash in blockchain and data on the cloud.
Uh, Normally, data and hash both will be stored in the blockchain. We can't have something like storing data on the cloud and storing the hash. And because even though you use that, you store cloud data on the cloud and you store hash on the blockchain. So whenever data is modified, ultimately you need to have a link where the hash is again remodified. So normally that is not the use case, right? So we can't store data somewhere and the hash somewhere. I think yeah, it's clear.
Yeah. Is that question answered, Nidhi? Any other questions? So yeah, Mr. Sandeep asks, what is role of blockchain in information technology?
Yeah.
Well, I think this question is answered in Rishi's session. So he was talking about all the applications and
Yeah.
how it has evolved and everything, right? Sandeep? Oh, I see that you're not attentive in the first session. Hmm? And do you know, Cisco WebEx has got this, it has got a very interesting analytics feature, wherein I would get a lot of analytics on the user behavior. So like how much of time a particular person is not attentive, so he's not at the screen, and lots of things like that. I was just watching previously who's doing what. Hmm? So hopefully you'll be attentive for the next session. But yeah, many people, about 60-70% were fully attentive, 30-40% were, here and there coming and going, but 10% were there who were totally absent at the screen, and we have the set, right? Yeah. So that is how information technology is evolving. We cannot make out sitting in a classroom what are 30 people in the class are doing. But here I am able to view every candidate's behavior here for a class of 250 students. Yeah, right. So the next question is Amita Goel. How to store medical images in blockchain?
Yeah. Actually, blockchain is not meant for storing images, but always you can store a hash of that image in the blockchain so that whenever you want to check whether the image has been modified or altered, so you can always recalculate the hash and check with the hash already stored in the blockchain. So blockchain is only used for like a transaction management and auditing. We store only the hash values. So images can be stored in the cloud and the hash of that can be stored in the blockchain and we can always check whether the images are modified or not. So that is one use case. Yeah, you can
And
do
we
that. Yeah.
we anyway have a session on healthcare, na?
Yes.
That hash and healthcare.
Hash everything. Yes.
So don't forget to attend that session, Namita. So while you get the answer in brief here, you'll have an in-depth explanation on that. I hope you have seen the schedule in the website. Okay, the next question is, can blockchain be used for solving the DDoS attack other than transactions? Yeah, we have one industry use case in this workshop. Yeah, Srinivas.
Yeah, it is a right question because most of these servers are centralized. So we are using blockchain because it is decentralized and it is very difficult to attack the from the attacker perspective. It is very difficult to attack all the systems at once. So definitely we are going through that use case in the next coming sessions. How to tackle DDoS attack using blockchain. So that will be very interesting session. I think you can get more, you can explore more in that use case and be getting more insights in that.
Yes, Bala. Like we have a whole session on the DDoS attacks and blockchain. Okay, so see that you attend the session attentively. And then comparison with blockchain and database.
Yeah. Okay.
Yeah,
So
here's the answer.
yeah, I think Rishi has answered most of the
Yes, yes.
points in this, but see, database is completely different and blockchain is a different perspective. So basically, the database is a centralized one, and we do have decentralized databases, but blockchain is a comes with a different perspective, like where it is immutable, and we use a lot of cryptography, and every transaction is hashed, and using private and public key we store the records. So these are all the various additional features we have for the blockchain. But in database we don't have all this. We may have, but this is decentralized. Most of the databases are centralized. Think it's clear, or you need more points in this.
Yeah. Next is what is this? Can I know the internal operation of generating nonce value?
Okay. So generally, nonce is a random value which is generated to see that you don't spend the same coin again, right? So there is a lot of logic in behind that. So I think I'll try to explain in the next session how a nonce can be generated in Ethereum. But nonce is generally a random value which is generated to see that the double spend problem is eliminated because it is a digital coin. At any time you can replicate the coin and you can spend the same coin with two people. So this can be eliminated using nonce value. So that's the purpose of nonce. Nonce basically it is a random value which is added.
Yeah, normally in randomness, because there comes a seed which is based on the time. So that time to the finest level of what do you call to the finest level possible is added to the hash, so it automatically generates a distinct value. So I think, yeah, this answer is perhaps clear, Kaushik. The next is, which is the most power efficient blockchain platform?
So coming to power efficiency, normally Bitcoin takes a lot of power, and when we talk about the proof of stake, the blockchain which uses proof of stake generally is less power, it will consume less power. So Ethereum is one of the blockchain which works again on. There are different versions. Like previously, they had a proof of work, but now slowly Ethereum is also moving towards proof of stake. Still, algorithms are not stabilized, but definitely proof of stake will be the better algorithm in when you consider in terms of efficiency or power efficiency. So because a lot of almost you need to generate tera hashes to match the blockchain address. So you need a lot of computing power, and that computing power needs a lot of power to generate that. So proof of stake or the algorithms which doesn't use that proof of work concept are always better than that Bitcoin. Especially Ethereum is better than Bitcoin blockchain.
Hope that's clear, Ajay. And the biggest drawback of blockchain is we can't reverse the transaction once made. Any solution to this? Ajay asks.
Okay.
Biggest.
Actually, the purpose of blockchain is to have only immutable records. But always, if there is a chance that you can update, so you can always go to the database. So it all depends upon the use case. For example, I will tell you a use case where you can't just manipulate the records. If you take clinical trials, so people, the laboratories are working on the cancer patients' records and all those things. They find some the findings that how the patient is getting cancer and what food habits and all these things. So this should not be never. This should be never manipulated, right? So normally government manipulates a lot of records, even in COVID cases. So a lot of manipulation is done. The real number will not be shown. So in such cases where we don't want to modify or there should not be any chance of modifying or updating, we should go for a blockchain. So you always want to have a chance of updating. So it's better go to a database rather than a blockchain. So specific use cases are there. You can't just have all the options in the one concept. So I think it's clear.
Hope that's clear, everyone. So for today, we are sorry because of this technical glitch, we could not somehow continue with the actual session. But hope the discussion was fruitful to you all. And but anyway, we will be like conducting this session in one of our future slots, and slightly we may take half an hour extra time next day, next 2-3 days. So thank you, Srinivas. And regarding attendance, we don't need any attendance. We directly take it from WebEx. The time you logged in, the time you stayed attentive, and when how many times you exited, everything we get. We don't take attendance. And so the feedback forms and all will be sent to you. So we'll post them in the Telegram link. Hope you have all got the Telegram link.
Okay, we also created WhatsApp groups for those of you who are not comfortable with Telegram. So you can use either of them. Okay, you can also join Telegram. Yeah, WhatsApp is also there. Both we have created. And you can watch the website for any updates. And we'll start sharing our material in a Google Drive. The link will also be posted in the Telegram or WhatsApp. But the thing is, like, you have to compulsorily be logged in with the registered mail only. So let us end it for today. And thank you so much, Srinivas Raju. So I
Thank you.
think we'll sort it out down today in the afternoon,
Yeah, sure.
so that tomorrow's session goes on well.
Okay.
Thank you.